Today we are going to be adding slope. Sorry, it's a little bit echoey in here. I'm recording in a different room than normal, but we're adding slope. That's going to be on page 72. And you actually have two foldables that you're adding today, so make sure you're cutting along the dashed lines. We're going to put the tall table with the 3 folds on the left and then the no slope and undefined slope on the right. Obviously, pause if you need time to get those in your notebook. Okay, we're looking at slope today and talking about how we can find slope in different formats. So hopefully at some point previous to this year, right, slope is a pretty common one. You've talked about slope being represented in multiple forms, right? We can say that slope is rise over run. We have a formula for it that says y2 minus y1 over x2 minus x1. This is the least common one, but we can also say that slope is change in y over change in x. Okay, and when we are looking at slope today, we are going to be talking about how we use each of those to our benefit. So if we're looking at a graph, the best way to find slope is by doing rise over run. So if we want to calculate slope from a graph, right? So here we're given graphs, we're given a picture, and we want to calculate the slope. Now, when we are talking about slope, okay, we are talking about how this line is angled. So what we are really looking at is how steep the line is, right? We're talking about how steep it is. And that is then going to determine, okay, which angle this is at. Now, you're also going to notice that one of these lines is going uphill and one of these lines is going downhill. If the line is going uphill, so if we have a line going this way, we are always going to be talking about a positive slope. Okay, if we have a line that is going in the opposite direction, or if it's going downhill from left to right, so if it's going this direction, okay, this is going to be a negative slope. And we're going to talk about how to get those values in there in just a moment. So if we're looking at these graphs, right, we know we're talking about how steep it is, and then we have one that has a positive slope because it's going uphill, and one that has a negative slope because it's downhill. You're also going to notice that here it asks us to say what m equals. Okay, and the key is that we are now adding a new letter. So m is the same thing as slope. We use the letter m to stand for slope. Okay, so when it's asking us what m equals, in your brain you should be saying, oh, m equals is the same thing as asking me to find slope. So I'm going to use a pen here for just a second because it's a little bit of a finer tip. But what we're going to have to do is we're going to look at this and we are going to decide when we look at this line 2 points. Whenever we are dealing with slope, we always need 2 good points. So obviously it's not a good point if we pick a point over here on the graph. Oh, that's not a fine tip apparently, right? That's not a good point because it's not even on the line. So that's a bad choice. Okay, it's also not going to be a good point if it's sort of here in the middle. So, right, it needs to fall right on the intersection, okay, of this gridded graph. So, for example, we know we have a good point right here on our y-intercept at -1. But it's not a good point on our x-intercept because that's falling at like 1.5, 1.3 something. We don't know exactly. So we want to wait until we can find a good point, and there are several of them. Okay, so there is a good point here. There is a good point here. It doesn't matter what good points you find as long as you find 2 of them. Okay, then once you have those 2 good points, you then want to go by rise over run. So that's exactly what we're going to count. We are going to see how much we have to rise to get from one point to another, and how much we have to run to get from one point to another. So you're gonna pick a starting point. I prefer to start at the lower point, but some students don't. It doesn't matter, you just need to pick a point. And you're gonna ask yourself, how many do you have to go up and down? How many do you have to rise to get to the same level as the second point? So if I start right here, how many do I have to rise? I have to go up 1, 2, right? And when I'm at this height, I'm now at the same level as that second point. So I went up 2. Okay, I then want to see how many I have to run or how many I have to go right and left. Okay, so from here, I'm going to count how many I have to go over. So I'm going over 1, 2, 3. So I'm going up 2 and I'm going right 3. Okay, we are always going to write the rise on top and the run on the bottom. It makes a fraction. So I went up 2 and over 3. Okay, here I know for several of you, you're like, oh, I don't really like fractions. Can I turn that into a decimal? And the answer is 100% no. Slope is always in reduced improper fraction form. Okay, so no mixed numbers and no decimals. It needs to be a reduced improper fraction. So now we're going to look at our second one. Okay, so same idea, we want to find 2 good points. So if I'm trying to identify 2 good points, okay, maybe I see a good point here on my y-intercept, which is just a coincidence that it's been on the y-intercept both times. It doesn't have to be. Maybe I see another good point here. Okay, again, like I said, I tend to start from the lower one, but you don't have to. Maybe you always want to start from the leftmost point. Okay, so how many do we need to go up or down? So if we want to get to the same level as this point, we are going down 1. Now, our rule says if we ever count down or left, the number needs to be negative. Okay, down or left, the number is negative. So since I counted down 1, that's a negative 1. Okay, then I'm going to see how many I have to count right. So I'm going over 1, 2, 3, 4, 5. Okay, I went over 5, that was right, so that is going to be a positive. So my M is going to be my rise over my run, or negative 1 over 5. That is reduced and that is improper. Well, right, it can't really be turned into improper, so that's our final format. No mixed numbers. Okay, our second option is that we can find slope from 2 points. So when we're finding slope from 2 points, we do have the option that we could plot the 2 points on the coordinate plane and still count rise over run, or instead we have a formula that we can use. Okay, we know that any ordered pair is a point x comma y. So we have 2 points that are x comma y. So to be able to tell these points apart, we're going to give the first point a subscript of 1. That just tells us that this is our first x and our first y. And our second point. Okay, then at this point, all we're going to do is substitute into our formula. So instead of saying y2 is now 8 minus y1, which is now 5. Now this subtraction sign comes from the formula, not from any place else. Okay, so we'll do the same thing here. x2, which is negative 3, minus x1, which is 1. So now we're just doing basic math. 8 minus 5 gives us 3. Negative 3 minus 1 gives us negative 4. Now, you can leave your answer as 3 over negative 4, okay, but the majority of the time, my students prefer that negative to be in the numerator, right? We've talked about this concept that we can't technically have a negative in the denominator. So one option is writing the negative out front, but my students don't like that as much because then it's which one gets the negative. So they typically pull that negative up into the top. Then you're still able to put it in your calculator, and you don't have any other issues with doing math in any other format. Okay, now let's look at our other one. Okay, so our second one says y2 minus y1. So remember, we have an x1 and a y1, and an x2 and a y2. Okay, so y2 in this case is negative 4 minus y1 is 8 over x2 is negative 2 minus, because that's part of the formula, right? The formula tells me to use subtraction, minus x1, which is negative 6. So this minus is coming from the subtraction in the formula, and this one is coming from the negative in front of the 6. So we have negative 2 minus negative 6. So negative 4 minus 8 gives us a negative 12. And a negative 2 minus negative 6, right? Two negatives really make addition, gives us a 4. Now, we always want this in reduced improper fraction form. Okay, so this is not simplified. So we need to take negative 12 over 4 and simplify it. That turns into a negative 3. Now, it is understood that negative 3 is the same thing as negative 3 over 1, but you could write that answer either way. So whether you have it as negative 3 or negative 3 over 1, either option would be fine. Okay. The last option is that we can find slope from a table. Finding slope from a table, we want to use the idea of a change in y over a change in x. Now, obviously, we don't have to. We could take this table and we could plot them in the coordinate plane and do what we did with the graph. We could take this table and turn this into ordered pairs and did what we did with the points. So if you say, you know what, I really just want to write this as 2 ordered pairs, that's totally fine. There's nothing wrong with doing that, okay? The key is that we still need 2 good points. So if we look at this problem, we actually have 1, 2, 3, 4 good points. We need 2 of them. You can pick any 2 that you want. Okay, I'm going to pick this 4, 6 and this 10, 15 because then I avoid the negatives, but I also avoid the largest numbers. And we're going to do very similar to what we did with the points. We're just going to look at it in table format. Okay, so we're going to ask ourselves, what do we have to do to get from 6 to 15? Now, some of you are going to be able to do that as easy mental math. Okay, and you're going to say, oh, 6 plus 9 is 15. We have to add 9. Some of you might not, and you might need to actually do 15 minus 6, which is still a positive 9. Okay, then we're going to do the same thing over here. What do we have to add or subtract to 4 to get to 10? Again, you might be able to do that with easy mental math, or some of you might have to do 10 minus 4. Okay, but we want our change in y on top. So we need our y side on top. So we need 9 over 6. That is not in reduced improper fraction form. So we need to get this simplified, which will be 3 over 2. Okay, this is still what m equals. It's still 3 over 2. Okay, for our one over here, this one has more decimals, more wonkiness. So plotting these points on a graph and counting rise over run isn't going to be a good choice, right? They're large decimals. Okay, but you could turn it into 2 ordered pairs and subtract, or do the same thing we did before. So I'm going to pick 2 points. This time I don't have any negatives happening, so I'm just going to pick my top 2 points because they're my smallest numbers. And I'm going to go the same approach. Now, in my head, I don't just magically know what that value is, so I'm going to do what I said we could do over here and take that 126.50 minus 5750, which gives me a positive 69. And on my other side, I'm going to do 11 minus 5, which gives me a 6. Okay, but there's a certain point that we need to talk about what's reasonable given the problem. So this table is talking about cost and hours. And when we talk about slope, we can also talk about what that means in a given problem. Okay, so yes, it's the rise over the run. Yes, it's the y2 minus y1 over x2 minus x1, or the change in y over change in x. Okay, but in this particular thing, our label is y per x. So we are really talking about the cost per hour. And if we are talking about money, it does not make sense to have our money in fraction form. So in this situation, we would want to divide this out and be talking about money and say that this is $11.50 per hour. Now, finally, we have a couple unique situations, just like we always have had, right? Sometimes odd things happen. And so that's what we're looking at over here. Okay, no slope and undefined slope. So let's talk about our no slope first. So if we open this up, okay, no slope These graphs are flip-flopped, but they will be correct in your printout. Sorry guys, your printout will be fine. So you're just gonna have to imagine these being flip-flopped. Okay, if we say our 2 points, that's our y minus our y over our x minus an x. So we're getting 0 over -7. If we do 0 divided by -7, okay, 0 divided by -7 is 0, or no slope. Okay, so you can say that this is the number 0, 0, or no slope, and all of those are correct answers. Okay, now, like I said, you have to imagine this is flip-flop. So this is the graph that actually goes with it. It's right in yours. Okay, no slope looks like a flat line. So if I pick 2 good points, well, I go up 0, there's no up and down, and over 1. So I'm still getting that horizontal line of no slope. Okay, as opposed to undefined slope. Man, your printout's gonna be right, mine's wrong. Okay, so if we're here, we're gonna say -1 minus 5 over -6 minus -6. Okay, so we'll get -6 on top, and we will get 0 on the bottom. -6 divided by 0 is undefined. If you put that in your calculator, you're gonna get an error. You can't divide up nothing. Okay, so this is gonna be our undefined slope. An undefined slope is always a vertical line. Okay, so if we look at this, again, we're going up 1 and over 0, which is also our undefined slope.